Hello.
Hi there.
Welcome back. I am Brian Mulligan, also known as AstroBit.
And I'm Sinclaire Manning, also known as Major Merger.
And before we get into the slides, we've got actually a more important piece of astronomy in the news. Didn't make it in time for press. Astronomy magazine has profiled astronomy on tap. So I want to thank you to our supporter who brought the magazine out for us tonight. Take a look at it on your newsstands right now. What's the current price of astronomy? I'm not seeing it on here. It's what, $10 probably? I don't know, something like that. Nice and cheap. Check out your local newsstand. Buy Astronomy magazine, a fantastic magazine. Lots of great magazine. Lots of information. I grew up reading this magazine, so please check it out. But a great write-up of astronomy on tap throughout the world. I don't think it includes Taiwan quite yet, but yeah, a fantastic write-up. Our pictures on the look there. Unfortunately, I don't have a document camera, but yes. So here we are. I don't know if you can see this at the north door. Astronomy on Tap ATX. Second page of the article. Thank you all for coming out here and making this the biggest Astronomy on Tap in the world. All right, now actual astronomy in the news, not just us. So October 19th, the Schiaparelli lander landed on Mars, not quite the way that it was intended to land. So it was named after Giovanni Schiaparelli. You probably know of him as the guy who came up with so-called canals on Mars. He was the first one to make detailed maps of the planet. He called them channels. Translation into English worked out to canals, and suddenly there was aliens. Now I need the History Channel meme. Okay, so Schiaparelli, what we've got here, a picture on the left of the lander itself, or the probe. The picture on the right is how it looks today. The one on the top is the probe itself. There's already a crater on Mars called Schiaparelli crater. It's down near the equator. It's about 400 kilometers in diameter. Now he has two craters on Mars. The second one, not so big. The other two pictures below it, so the top one is the lander itself. You can actually see a couple of bright speckles that are probably equipment associated with the lander that kind of got blown out in the explosion or in the crash. The bottom one's the one on the left is the parachute. This is kind of fun. I couldn't manage to get all the pictures of it. We can actually see the parachute flapping in the wind over time. So we've taken multiple pictures of it. We are certain that that's the parachute. The one on the right is the heat shield. So the lander was part of a European Space Agency program to land a probe on Mars. It actually wasn't going to last very long. This was mostly a demonstration program for the next European Space Agency project to land a probe on Mars. It didn't work out so well. So odds are the ESA is out of the Mars lander business. The last time ESA tried to land a probe on Mars was in 2003. There was the Beagle 2 lander that was supposed to arrive on Christmas in 2003. That went about as well as this one. So yeah, I think they're done. It was pretty cool. It was supposed to work out. A couple of the problems, the parachute that they had. So the parachute, the one that you see on the left, it's separated about a minute and a half too early, if I'm recalling correctly. That's a little bit too early for it to survive safely. Well, there was a rocket that was also supposed to help it slow down, and the rocket also basically failed. It was supposed to fire for a couple of minutes to slow the probe down. It fired for about 30 seconds. Combination of no parachute and rocket not firing long enough means big crater. The mission is not a total loss. The tracer gas orbiter was another component of this mission that is still in orbit around Mars. The tracer gas orbiter is going to be looking for signs of methane and water in the outer reaches of the atmosphere of Mars. Planet Hunter was just talking about biosignatures on exoplanets. These are biosignatures for Mars. So water, we already know certainly exists on Mars. Methane, we know exists on Mars. Methane on Mars is a little bit unusual. It shows up a little bit more than we expect. The tracer gas orbiter is going to be mapping where the methane on Mars is. That actually might provide evidence to us of the presence of life on the planet. So keep your ears open, keep your eyes open, keep reading the news. We might figure out where the important sites for life on Mars are in the next couple of years.
All right, clicker. Some of you, if you were here last time, know the struggle, the battle I had with this clicker. You might not be able to recognize this planet without its signature rings, but this is actually Saturn. And NASA's Cassini spacecraft, which has been orbiting Saturn since 2004 and is expected to end its mission in fall of 2017, has captured this curious color change on Saturn's north pole. So as you can see, the image from November of 2012 shows this bluish halo over the pole, but the same area in September of 2016 is now a bit more golden looking. And so Saturn's North Pole has a unique six-sided jet stream, which you can see, which is known as the hexagon. And it's approximately 20,000 miles wide, and the winds of this vortex are on average around 200 miles per hour. So in the color change that we're seeing, scientists actually believe it's because of Saturn's seasons. So Saturn has a 7-year-long winter, which, Brian, maybe growing up in Wisconsin, you kind of know something about that.
Yeah, it's about the same.
So Saturn experienced its equinox on August of 2009. And since then, it's been subjected to more and more sunlight as it approaches its summer solstice in May of 2017. And because of all this increased sunlight, there's been an increase of these photochemical hazes in the atmosphere. And so as it's approaching the solstice and more of these hazes are being produced, it's thought that that's what's created this hue.
Okay, next up. Oh, I didn't know we added the background to this one. Okay, so axions. If you were here 2 months ago, was I talking? I think
yes.
2 months ago, I was talking about dark matter. I mentioned one of the possibilities for dark matter is axions. We've got new information about axions. So axions give you a little bit of background in explaining what's going on. Most particles have some sort of charge, a positive or negative charge, and they also have spin. So they're either kind of spinning clockwise or counterclockwise. And if you take a particle and put it in a mirror or in a physics mirror, it will flip both its charge and its spin. So it will go from a negative charged particle to a positive charged particle, and it will go from spinning clockwise to counterclockwise. For the most part, that's fine. But there's a funny thing that when we work out all the physics of how the forces of nature work, the strong force, the force that holds atomic nuclei together, that holds protons together, holds. So we've got a diagram here of a proton with two up quarks and a down quark. So the strong force is holding that proton together, holding all those components together. There is no reason whatsoever that the strong force actually follows this. The strong force could actually say, no, I don't really want to change the charge, but I'll change the spin. Or I'll change the charge, but the spin's fine as it is. It's a really funny, weird mirror. There's one thing that we as physicists and astronomers don't like. It's something called fine-tuning. You can make a force that works this way if you exactly specify the parameters by which the force works, and they have to only be a very specific set of parameters in order for the force to work that way. And we don't like that. We generally like things that we say, well, it can be anything, but all of these other things force it to work in a particular way. Instead of like just randomly picking out parameters and the parameters happen to work out the right way. Well, axions are the explanation for this. Axions are a theoretical construct that say, okay, when we make the strong force will work out that it allows for this weird mirroring symmetry of particles. So we call this charge parity symmetry. Axions are a method of doing it. Axions are also a dark matter candidate. So one of the possibilities, if you recall my talk, if you were here, WIMP dark matter, we're starting to lose faith in. It's not working out terribly well. So our other options are black holes, weird theories of gravity, or axions. And so axions are like, okay, we can detect those perhaps, but we need to understand a little bit more about them. Well, fortunately, this last month, I'm going to butcher this name, Szablak Borsiani of the University of Wuppertal in Germany, and his team, which is pictured here, used supercomputer simulations and calculations in order to figure out exactly how massive an axion is. This is an outstanding question. Using a supercomputer means that it takes a hell of a lot of calculations in order to do this process. So they worked out what the mass of an axion is. Their answer is 10 to the minus 18 times the mass of an atom. I'm not even quite sure how to put that into words that I can describe to you guys. A 1 after 18 zeros times the mass of an atom, that's something like a 1 after, I don't know, something like 40 zeros of the mass of all of us. So really, really, really tiny. In effect, that means there's about 1 trillion of these particles for every cubic centimeter in this room, if these actually work out. So this is very exciting. This gives us an opportunity to actually now try to figure out how to measure these. There are experiments in process that are trying to measure these, and now that they've done this calculation, those experiments can start to fine-tune their planning and experimental apparatus to figure out if they can detect these tiny, tiny, tiny particles and perhaps finally answer one of the biggest questions in astronomy today.
I don't know why that background is like that. But anyway, all right. So my space cadet name is Major Merger. So obviously, any chance I get, I'm going to show you guys an image of a really awesome major merger between two galaxies. And so this is the beginnings of a major merger that have been imaged by ALMA, which we heard about from What a Merger Jr. So yeah, ALMA is the Atacama Large Millimeter Submillimeter Array that's located down in Chile. And it has imaged the carbon monoxide gas shown in red here, which is overlaid on top of a Hubble optical image. And so while these major mergers aren't particularly rare, Dr. Michelle Kaufman, who's the lead author on this work, says that only a few have been seen to have this kind of ocular structure. So particularly in the left side galaxy, you can see it kind of looks like an eyeball. And so this system resides around 114 million light years away from Earth, and it is expected that eventually they will completely coalesce into one system.
All right. Next up, it's time for my monthly rant. So you might have heard of this article that came out this last month. The official title was Marginal Evidence for Cosmic Acceleration from Type 1a Supernovae. The short version of that title is There is no such thing as dark matter. This thing that we've been chasing for the last 16 years. The entire purpose of building the dark energy experiment, or sorry, not dark matter, dark energy. The entire purpose of building the dark energy experiment out at McDonald Observatory, just a big waste of money. Okay, so what they actually did was they looked at evidence. They did what's called a meta-analysis of data from the last 20 years, basically, looking at Type 1a supernovae. So Type 1a supernovae, do we have? Yeah, we do have. This is actually what I study myself. Over here, we've got a couple of examples of these. Basically, we've got something like a tiny little star, like what our sun will eventually turn into, and another star next to it that feeds material into it, and that star goes to a certain size and it blows up. And these are fantastic probes for understanding how our universe evolves over time. How, you've heard of how the universe is expanding. We can use these to figure out exactly how the universe expands, or at what rate the universe expands. Back in the 1990s, we figured out that the universe is expanding faster over time, what we call cosmic acceleration, and we've given the name to explain that as dark energy. Basically, something that's causing acceleration, and we don't know what it is and can't see it. And so their research said, okay, we're going to look at these supernova, and now we've got an additional 20 years of data, and what can we learn from that? And so what they did was they produced this plot. Here we've got how much matter there is in the universe, how much there is of us and dark matter, and then up here how much there is dark energy. And they said, well, there's about a 70% chance that there's roughly 50% dark energy and something like 20 to 30% matter. But they said, oh, there's a chance that we're over down here where there is 0 dark energy and 0 matter. Now, I'm pretty sure that we're all here. What's going on? So this is yet another scientist frustration for the month of October. What they did, I would posit they actually did a very good analysis of the supernova data. But one of the problems here is that they failed, when they submitted their paper for publication, they submitted it to a journal that is not for astronomy. In fact, I have never in my life heard of the journal that they submitted this paper to. It was accepted for publication. I suspect that whoever checked it for publication did a good job of checking their statistics and checking their math and all that sort of thing. But one of the problems is that they failed to account for all of the rest of the evidence in the universe that says that dark energy does in fact exist, and for that matter that we exist. So uh-oh. There we go. All that for just one little oval. So what I've plotted up here on their graph, what I've added into their graph, is the rest of the evidence from various methods of observing the universe and trying to decide how much dark energy and dark matter that there is. That oval is the highest probability oval of how much dark energy and the rest of stuff that there is in the universe. And as you can see, we're still consistent with about half the universe or more being dark energy, the rest of the universe being matter. Essentially, what the problem came down to here is they produced an article with a misleading headline. Not that any of those ever occur, especially in the last election cycle. And in addition, they produced a press release that said, hey, we figured out that dark energy might not exist. And that sounds really, really, really exciting because it's going to turn the world on its head. Except that they failed to account for all the rest of the evidence that there exists in the world or in the universe that there's this other thing. The addendum to my rant is this is a common problem. How many of you have seen fad diets? How many of you have seen evidence that, kale is going to cure you of all of your cancers and every other malady that you have? You need to account for all the information that's available to you, and this group failed to do it. I think they did great science, but they failed to account for all the possibilities and all the information that was available to them. As consumers, as all of you read the news articles, please keep this in mind. Often the news gets it wrong. I don't want to rail on the news. Journalists do a fantastic job. They've got a really hard job, especially science journalists who, don't have the training that we have here. But keep in mind that they don't have the training that we have here. All right.
Astrobit out. All right, last one, folks. some of you may have seen this in person. This was the life-size replica of the James Webb Space Telescope that was here during South by Southwest a couple years ago. But I put this up here because the JWST is actually complete. They finished it.
You did it.
So after more than 2 decades of construction and $8.7 billion later, the world's largest space telescope is ready for launch. Sort of. There's a caveat to that. But so this was announced on November 2nd at NASA Goddard Space Flight Center in Maryland. So JWST, the successor to Hubble, which will be much more powerful, and collects infrared light, which Hubble is not sensitive to, is almost ready to go. And so as exciting as this is, JWST still has to undergo a lot more tests, so it's going to stay at Goddard for a while they test it to make sure it can undergo the shaking and all the noise that comes along with a launch into space on a spacecraft. And then it'll be moved here to the wonderful state of Texas to test the focus of the instrument, and then it will be shipped over to California for final assembly. So it's doing a little world tour almost. And then finally the launch, which is currently scheduled to take place in October of 2018, will happen down at the European Spaceport in French Guiana, which is in South America just near the equator. But a lot of astronomers, almost every talk you guys hear, like the end is JWST, we can do more. And so we are that much closer to getting there. So, yep.
All right. Thank you very much. That's it for Astronomy in the News for November. Thank you.